Hello everyone, and welcome to this weekly session, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their queries or doubts related to any RCC steel design concept or construction site related queries or any specific project that they're doing. So this is the 74th such session that we are conducting. And let us begin by taking the queries that have been asked for this week. So first we will take the queries from Google form, and then we will take the queries from live audience. Okay. So let me just share the screen. I hope the screen is visible now. Yeah. So the first query has been asked by engineer Saif Ahmed. He is from Guwahati, and he is asking, how can I determine the thickness of checkered plate? How can I determine the thickness of checkered plate as per IS 800 2007 if I have a load intensity of 4 kN per meter square and span of 2.5 meter? And how can I check whether the thickness of plate provided is okay or not? If I want to design the checkered plate, what are the things? See, checkered plate design is just like your slab design. Okay, just like you do your RCC slab, same thing you have to do for checkered plates. Now, first you need to understand or find out that is your checkered plate two-way spanning or one-way spanning. So for that you need to know how the checkered plate is getting supported. So it may be the case that, let's say, I'm showing you the plan view, and this is the checkered. These are the beams. Orange are the beams, and you are placing checkered plate like this. So because the supports are only on two sides, this will essentially become one-way spanning. So now if it is one-way spanning, then you have to find out the moments for the load, just like you do for W becomes your load intensity. Okay. And accordingly, you can just find out the moment divided by some coefficient depending on what sort of continuity, whether or not continuity is being provided or it is simply supported. Depending on that, you can figure out this n factor. Once you know this, then you can equate it to, let's say, sigma into z, where sigma is the bending stress that your steel plate can take. Now, for all practical purposes, you can assume this to be in you can assume this to be in class C. Okay. And therefore you can just take the stress level as Fy upon gamma m naught into Ze. Understood? So you can allow Fy, because there is no issue of buckling, etc. So you can take Fy gamma m naught upon Ze, and Ze will be, let's say, B into T square by 6. Now because you are taking the moment values are in kilonewton meter per meter, because you are doing it for 1 meter width, so you can take this to be 1 unit, and this accordingly you can find out this thickness. So similarly, the way in which you do your slabs, RCC slabs, the same principles you can apply it over here to find out the checkered plate thickness. So this will be strength design. Then you can check for the deflection also. If your checkered plate is two-way supported, that means it is resting on multiple beams from all four edges, let's say, and this is your checkered plate panel. Then you can use the same concepts of our two-way slabs that we use in RCC design, and you can use the coefficients, moment coefficients from IS 456 you can use, considering this to be interior panel or one side supported. All those things you can basically take into account for this checkered plate also. So the design of checkered plate will be similar to what you do for your normal RCC slabs. Okay. If I want to design the checkered plate, so these are the things you need to keep in your mind. And generally, what happens is that checkered plate suppliers give a standard table with their product, and they save our efforts, the designer's effort basically, by giving a standardized table where they will give you, let's say, a shorter span. Okay. And assuming all four edges are supported, for what short span, how much load intensity it can resist. So those sort of tables also you may get sometimes. Otherwise, you will have to do such a thing on your own. Now, sometimes for checkered plate, you may have to give secondary members, because what happens is that your beam, primary and secondary beams, may be at uh, larger spacings. So, for example, this is your framework in plan view. This is your some beam framework. Okay, and let's say this was 4 meters, this was 6 meters. Now, if you go on to design a checkered plate for this much span, it will be very, very thick checkered plate requirement, which may not be suitable. So what we do is, in such cases, we may put some tertiary members for checkered plate support. So now I will put my checkered plate like this, and essentially because I have put my sorry, essentially because I have put my tertiary members in this direction, I can make a checkered plate spanning like this and find out the thickness. So first you will need to uh, do the framing and see what type of framing you can provide. Accordingly, you can then find out the thicknesses as per moment calculations that I just explained. Next question is from engineer Rohit Kashyap. He is a working professional from Guwahati. He is asking, how do I calculate wind load on purlins and curved truss? So for curved truss, there is a figure given in IS 875 Part 3. I'll just show you a screenshot. You may use that figure and accordingly find out the. So this is the table 18. This is given for curved roofs, and whatever is your case, if it is a case where you have a riser like this and then you have a curved roof, the coefficients are given for different wind directions. So once you know the coefficients, then you can calculate the wind load on purlins. Now purlins are perpendicular to the screen right now, but if you know the coefficient, you can just simply multiply the uh, coefficient into the whatever wind pressure that you get into the purlin to purlin spacing to get the wind load distribution on purlins. Okay, so in this manner you can calculate. There's a very good explanatory, you can search it on the internet by the name of W06 solved examples for wind, prepared by Dr. Abhay Gupta sir. So you can get it on the internet, freely downloadable. If you don't get, you can message me. So in this, there are 28, 29 solved examples for wind loads. So most of the cases that we come across, usually I have been covered. So you may refer to this document if you wish to do so. Okay. Is my voice audible to all of you? Okay. Next question is from engineer Harish Acharya. He is from Mangalore, and he is asking, in safe software, is asking in safe software, while designing irregular shaped foundations, how to get the reinforcement contour. So safe will give you the reinforcement contour. Safe will give you the reinforcement contour. You will not have to do anything. Safe will give you the contour. And how to do the detailing. So that detailing will depend on what sort of shape you have and what are your, let's say this is your plan view. Okay. Just an example, and these are your columns. Maybe it was a combined footing, irregular shape. You look for the contours. Accordingly, you find out the reinforcement requirements. Now, you may have to, let's say you provide a mesh, a standardized mesh like this. So naturally, the bars will be different lengths because the shape of the irregular foundation is such. So you don't have to give, I mean, that will be done on site. Okay. You just find out the, let's say, a bottom mesh. So your bottom mesh comes out to be, for example, 12 at 150. So just give 12 at 150 as your bottom mesh maybe. And let's say below your columns, you require another additional mesh like this. So you give just that, you give this length, that what is the extent of the this mesh, what are the bars, and maybe in between top you require some extra top reinforcement, so you give it in the mesh form. And don't bother about finding out the cutting lengths, that will be done on site by the contracting agency. So whatever is the shape, the contour will be given by the safe itself. You will get the reinforcement contour, you look at the contour, see what are the extents of the contour, accordingly find out the reinforcement. These things we have discussed in detail in our foundation design course. Yeah. Next question is from engineer Shiva. He is from Vishakhapatnam, and he is asking, in case of construction of pile foundations near, okay, he has two questions. In case of construction of pile foundation near seashore or creek, the lateral load capacity of pile is very less. In such cases, what is the governing criteria for design? Both compression load and lateral load capacities or compression load alone? Question is how to increase the lateral load capacity of piles in such condition. Now see, you have to check your pile for all the possible cases. Check the pile for all possibilities. So whatever is the compression load, your piles should be able to take that much compression. Whatever is the total tension, your piles must be able to take that tension. And whatever is the total lateral load, your piles must be able to take that lateral load also. It's not as if near the seashore the lateral load capacity is less, in inside inland the capacity is more. Not like that. Lateral capacities for piles are generally low. Okay. So as compared to compression tension, lateral capacities are always low. So you need to design the system accordingly, configure the system accordingly. How to increase the lateral load capacity of piles? See, directly you cannot increase the lateral load capacity as such. To cater to the lateral load, maybe you have to increase the number of piles, total piles. That means, suppose whatever your structure was, you are requiring, let's say, 4 piles, and in 4 piles compression, tension, etc. was getting satisfied. But because lateral was not getting satisfied, maybe you will have to add more number of piles just to satisfy the lateral load. Okay, lateral load requirement. Or else you may think of adding, uh, you think of adding something like a shear key. Okay, like we provide a shear key in retaining wall, you may think of doing that in your pile cap. Now again, it depends on the structure that you are designing and what is the configuration, all those things which I know, which I don't know what you are designing exactly. But then you can think of integrating some sort of shear cap like this. Okay, so that, and these are your piles, let's say. So this shear cap will help you to take some amount of lateral load. So not shear cap, shear key. The shear key will help you to take some sort of lateral load. Again, that will depend on your configuration and structural design. So this can be one of the options, or you can come up with a solution where you tie this thing to another column provided with more number of piles. So if this was your primary column, this you provide as a tie column with more number of piles to take that lateral load. So examples can be many, and I mean you need to accordingly figure out what is the best suited approach for you. Second question is, what is the relevance of clause 7.2.7 in design of buildings with lateral frames with shear walls? 7.2.7, which code, which clause are you talking about? In shear wall design by using ETABS, what is the basis of considering CNT design approach or uniform reinforcement or general reinforcement? See, in ETABS, it will not do the boundary calculations, boundary element calculations. So ETABS does not do the boundary element calculation. That needs to be done manually by the user. So what you can do is, do not take the CNT approach, because CNT is a very simplified way of designing what ETABS uses, and it totally disregards the web portion of the wall. It is, I'm showing you the elevational view. So it totally disregards the web portion and its moment carrying capacity. So don't use the simplified CNT approach. Use the uniform reinforcement, or you can define the reinforcement in general reinforcement and then work out the boundary elements on your own using manual calculations. So these type of calculations we have done extensively in our courses, so you can have a look over there also. And yeah, I mean, use the uniform reinforcement or define the reinforcement using general reinforcement. Don't use the CNT approach. Your second question is not understood. Relevance of clause 7.2.7. I have not understood this question. Please provide some more details in the question that you want to put. Okay, next question is from engineer Mehdi Ali Khan from Kolkata. He is a working professional. He is asked, he's saying, please discuss about bracing in steel structure, especially horizontal bracing. Now, what is the question you want to ask? What is the question over here? If there is any specific question, you may please ask. What do you want me to discuss? That is not clear. So if you have any specific query, please ask. Next query is from engineer Vinayak. He is from Bangalore and he is a working professional. He is asking regarding the lugs design and orientation of lug is important. I have attached images in WhatsApp. Let me see WhatsApp images. So this is the plan and this is the side view. I'm not sure what the query is, but what I can see from here is, okay, this is the side view. Yeah, see, orientation of lugs is important, as in that this sort of the length of the lug that you're providing, okay, this should help you to provide some resistance to the tension force, okay, and if there is some movement, then should help you to provide that resistance. So accordingly, you can think of orienting your lugs over there. Understood? So depending on your action, force action, you can figure out what is the best suited orientation of your lugs. So if it's a tension pull, maybe the orientation may not be so important in case of this column and I think it's a column base plate connection. But in some situations, the lug orientation may become important, and over there you have to see that which is the best suitable orientation for your condition. Okay, so yeah, this was his query. So we have taken up all the queries from the live audience. Now I'll take the queries. Sorry, we have taken the queries from the in the Google form. There are no queries on the email. So now I'll take the queries from our live audience. So Sumit is asking, according to the IBC, even when wind load governs the design, why are seismic forces still required for ductility detailing? Could you please explain the rationale behind this requirement? See, very good point. Point is also raised in this point is also raised or sort of discussed in, if you look at the ASCE 7 commentary to chapter 2, I think clause is 2.1 something. Over there also they tell you the same thing, that even though wind may govern, but still for seismic forces you need to provide the ductility detailing design. The reason is very simple, because you we do not design the EQ for the elastic level forces. That means we are not designing for the actual EQ. Okay, what are we doing? We are designing for a reduced EQ. So we divide the EQ by R, response reduction factor. So because we are designing, this is our basically the earthquake philosophy, isn't it? That we do not design for the actual earthquake force, and rather we design for a reduced EQ. And then because we are reducing this EQ by a factor of R, we will basically we want the damages to occur in our structure, inelastic damages to occur in our structure to dissipate the energy. And because of that, we are designing for reduced EQ forces, so that the balance of the earthquake force gets dissipated in the damage that it causes. So because of this, we need the ductility, because the balance force, that let's say 1 minus EQ by R, for this force we are allowing damages in our structure, but because of those damages there should not be any brittle failures or collapse. So that is the reason why we want ductility to be in our system. All right, so even if wind is governing, but still you are in a certain seismic zone, and for that seismic zone there is a probable EQ force that can hit your structure, and because you are designing for reduced EQs, you need to still provide the ductility requirements. So what you can do is, if let's say if you want to avoid providing the ductility requirements totally, do not divide your EQ forces by R, and just see or just check for the full EQ force. You understand? So what I am saying, let's say you have a wind force W, you have designed your structure for wind force W, and you are designing for EQ upon R. So the court said that even if W is governing, still you need to provide the ductility and detailing requirements. So what I'm suggesting is that you do it like this: that you take W, design your structure for W, and design your structure for EQ without using the response reduction factor. If without using response reduction factor also your wind load is governing, then you need not provide any ductility requirements or ductile design detailing requirements, because you designed for the full EQ load and checked for the full EQ load without any R factor. So this is my opinion on your question. Okay, all right. So this was the only question asked in the live chat. So any other query? Amir Sohail is asking, according to ACI and IS codes, what is the required anchorage length for cantilever reinforcement? Should the top reinforcement be extended by 1.5 LD or two times? Yeah, it is generally recommended. If you look at the SP34, It is generally said that in the case of cantilevers, you should extend your reinforcement uh, to 1.5 times the cantilever span. So it's a back span that you are providing in terms of reinforcement. So this you find in SP34. There is not a direct criteria given in the ACI code as such. Okay. All right. Any other question? Do we have any other query? Mr. Magaj is asking in RCC jacketing for ground floor column, what is the detailing at junction of beam, slab, and at footing? So for footing, this is your column, and if you are doing the jacketing for footing at the footing junction, you can let's say you can drill the new reinforcement inside your footing top surface. Okay, and you can provide some stirrups like this. So this can be the detailing adopted for your footing to column junction, where you have a footing, where you have a beam and column. Things may become complicated. So let's say this column is terminating over here. You can again just drill the reinforcement inside, and that's it. But if your column is going to continue, it will be slightly tricky. Let's say I'm showing you the elevational view, and you have jacketed the column. So column is now of a larger size. So now this becomes slightly tricky. Maybe the at the common reinforcement. So maybe you may not be able to do it through drilling. So maybe your bottom reinforcement stops like this after doing the drilling, and then you again plant a new reinforcement by doing drilling like this. Okay. Now it is possible that some of the reinforcements have to be passed through the slab. So it all depends on your actual configuration and what size and what is the actual scenario that you're having. But yes, you may have to drill through the slab or provide drill holes in beam, and where you can sort of anchor your reinforcement through chemical anchoring. Okay. These can be one of few of the options. Of course, it will depend on what actual situation you are having. Okay. Anything else? Can we make dummy footing as excavation is not possible? What is meant by dummy footing? The loads have to be transferred to the footing. I'm not sure what is meant by dummy footing. The column load needs to be transferred somewhere. So if your column load is increasing, because of which you wanted to do the jacketing, that increased load has to be transferred to the footing. If that old footing is capable of taking the additional load, well and good. Otherwise, somehow you have to make some arrangements so that the additional load of the column is going to be safely taken by your footings. Okay. I'm not sure what dummy footing means. Yeah, you can have new footings. You can have new footings as long as the column loads are going to be safely transferred. You can have new footings. You may cast a new footing over the existing footing to increase the size. Those things can be done. Yeah. Any other query we have? So the next course that we will be starting with will be the, as I have announced already, will be the composite design course. We will soon provide you the details. It has been a long time. We have not provided those details. We announced the course a couple of months ago, but we have not still provided any details. So now, within this week, hopefully the details will be out. Composite design, steel plus RCC, using ETABS and manual calculations. And we will, in this course itself, we will explore the Indian codes as well as the American codes. Okay, so we'll be doing the IS code as well as, so there is no separate American code for composite designs. It is included in the uh, parent steel and concrete code itself. For Indian codes, we have a different code other than 456 and 800, that is 11384, which we will be covering. Mr. Magaji is asking how to tie the footing reinforcement. Since we have column, do we need to drill to pass the footing reinforcement at column location? Yeah, that's what I said. You need to drill your reinforcement in the footing, and this is the new reinforcement which you need to drill inside your footing. See, it will all depend on your configuration, and unless I do not know your exact situation, it is difficult to answer. You need to apply standard, I mean, logic, that your reinforcement should be developed, the load should be transferred. Accordingly, you should come up with your system. Okay. Okay. Any other query, or should we close today's session? So I think there are no more queries now. You can continue to put your queries in the Google form. The link for the Google form remains the same, and you can keep providing your queries or keep putting your queries in the same Google form. And once every week when we meet, we will take up your queries. Okay. So this is the link for the Google form. And if you want to connect with us directly on WhatsApp, then I am just putting the link through which you can directly connect with us on WhatsApp. So I'll just put that link also. So throughout the week, you can just continue or keep putting your questions. And when we meet you every week, we take your questions there. So I think that's all for this week then. Thank you very much for joining, and keep putting your queries, and we will see you next time now. Until then, have a good time and bye bye. Thank you for joining.